Thanks for joining me in today's lesson. In this tutorial, let's solve literal equations or formulas for a given variable. Before we start solving our literal equations, let's look at an example from last class. Here is a linear equation in standard form. Let's graph it using our x and y intercepts. To find an x-intercept, I simply cover up the y term, because if y equals 0, that term would go away, and I'd be left with 2x is equal to 8. This is a simple one-step equation. I just have to divide by the coefficient of 2, and I will have that x equals 4. That means that my x-intercept is 4, 0. The y is 0, the x is 4. I go to my x-axis, 1, 2, 3, 4, and plot a dot. Great. Let's go find the y-intercept. To find a y-intercept, I cover up the x term, and in that case, I would be left with 3y is equal to 8. Another one-step equation, I just have to divide by 3, and I will have that y equals 8/3. I might want to see that as a decimal to help me graph. That would be 2.6 repeating. So my y-intercept is 0, 8/3, but if I'm going to plot it, 2.6 repeating would be approximately right there. So let's get out our straight edge and connect those two dots with a nice straight line. And let's put arrowheads on it. I wanted to show you this example to show you that sometimes graphing by x and y intercepts is not going to be the best because we might need to approximate a decimal equivalent. We would like to learn a different method for graphing lines, and that's what we're going to explore in a few lessons. But to do that, I need to teach you how to solve for y. When we solve for y, we're going to put our equation into a different form that may be easier to graph. When we're solving for y, we're simply getting all the numbers and terms away from that variable. I like to box in the letter that I'm going to solve for. And if I need this to be all by itself, this 2x needs to go away, and this coefficient of 3 needs to go away. So it's just a two-step equation. I'm going to get rid of the term first. This is just a positive term, so if I want to move it, I will put the negative term underneath it. I have to do it on that side, and I have to do it on the other side. So let's put negative 2x on each side of the equation, and let's cancel that away, because 2x minus 2x is 0. I'm left with 3y. Now notice over here I did not put the 2x or the negative 2x underneath the 8. These are not like terms. One term has the variable, the other term is just a number. So they will just go side by side. They cannot combine. I like my variable term to come first, so I'm going to put negative 2x first. And then the 8 will come second. And since it's positive 8, I need to see a plus sign. Okay, now I need to get rid of this 3. So I'm going to divide by the 3 since it's being multiplied. I divide the entire side by that 3. This will cancel away because 3 divided by 3 is 1, and then y will be all by itself, which is what I'm trying to do. Now, if I have two different things I'm dividing by 3, I like to divide them individually. So negative 2x divided by 3, I'm going to write it as negative 2/3 x. And 8 divided by 3, I'm going to write it as 8/3. Of course, I have the plus sign in between them to separate my two terms. So this is the form of the equation that has been solved for y. We're going to learn in a later tutorial that this represents the slope of our line and that this number represents our y-intercept. But we will get there later. Let's look at literal equations. Literal equations are equations in which variables represent known values. These are usually formulas, and there can be many letters. Remember, we are not solving for a number, we are solving for an expression. We did not solve this y to get y equals some sort of number, we got an expression that is equal to that variable. So let's explore. Example number 2. It says that we want to solve for w. Well, this example actually has three different variables, a w, a y, and a z. I want to solve for w, which means I want to get everything away from w and have w be the only thing on that side. So I need to get rid of this 6, and I need to get rid of this negative y. I think it's easiest to get rid of terms first. So since this is a negative y, I'm going to put a positive y underneath it. I have to put that on the other side. I'm going to put it not right underneath because z's and y's are not like terms. Draw my line and cross out that term. I have w divided by 6, and that's going to be equal to, I'm going to put 2z plus y. They're not like terms, so I have to write them side by side. I do need to get rid of this 6, so I'm going to multiply by 6. I'm going to put this entire side in parentheses and multiply by 6. I'm going to put this entire side in parentheses and multiply by 6. This 6 is there to cancel out with the denominator of 6, and I will have w all by itself. On this side, I don't want to leave parentheses, so I will distribute. 6 times 2z will become 12z. And 6 times y will be 6y. And that's it. W has been solved for, and I got the expression that it's equal to is 12z plus 6y. All right, let's look at another one. Here's a formula. The circumference of a circle has the following formula. Let's solve for the radius, which is r. So let's see where my radius is. I see it right here. I'm going to box that in. I need to get r all by itself, which means this 2 pi needs to go away. Since 2 pi is being multiplied by r, or 2r, I'm going to divide the 2 pi away. If I divide one side, I have to divide the other side. 2 pi cancels out with 2 pi, and I will have r all by itself. Over here, and I'm actually going to write it over here because I like r to be on the left side, I have c divided by 2 pi. Well, that's all I'm going to leave. C divided by 2 pi. Once r is all by itself, you've solved. There's nothing more to do on that side. We're finished. Let's look at example 4. It looks like we have 3 variables, but we really only have 2. 2 of my terms happen to have the m, and 1 of my terms happens to have t. I want to solve for m. Since I have 2 different terms that have the m, I need to combine those somehow, but they're on different sides of the equal sign. So I need to subtract one of them over. I'm going to subtract m and subtract m. This time I'm putting it right underneath this term because they are like terms. Draw my line, and this will cancel away. 2m take away 1m is simply m. I have minus t next, my equal sign, and over here is the 5, and I don't need the plus sign anymore since it's all by itself. I'm trying to get m all by itself. I like to box it in. That's what I want all by itself, and this negative t should not be here. So since it's negative t, I'm going to put positive t right underneath it. I'm going to put positive t over here as well. Again, not like terms, so I'm not putting them underneath each other. These are like terms, so I put them underneath each other, and I'm going to cancel them away. M is all by itself, and over here I have 5 plus t. I personally like to have the variable first, so I'm going to write it as t plus 5. But if you wanted to write it as 5 plus t, that would be perfect as well. And that's it. M is all by itself, so I have solved for m. One more. Let's solve for x. I see an x, I see a y, I see a z. I'm trying to solve for this x right here. Now this 6 is multiplied to x. I usually like to do my division last. So let's get rid of this term and let's get rid of this term. I'll do them separately. Let's subtract the y first. I'm going to subtract y from both sides. I'm going to draw my line and I'm going to cross that out. 6x and then minus 2z equals, I'm going to put my y term first, negative y, and then the positive 4 will come second. I'm not done. I still have 2 more things to do. I need to get rid of this term, and then I need to divide by 6. So let's get rid of this term first. Terms are moved by addition and subtraction. Since this is a negative term, I'm going to move it by adding. And there are no like terms here, so I'm going to put it all the way over here. I would not want to confuse myself by putting it underneath one of these 2 terms because it's not a like term. This will cancel away. I have 6x all by itself. I like my variables to come first. Y is alphabetically first, so I'm going to keep the negative y. And then I'm going to put the positive 2z. And that 4 will be pushed even further away right here. I have one more step to do. I'm going to divide by this 6. divide by 6, divide the entire side by 6. This cancels away, and I have x all by itself. Now, I have 3 fractions that I want to write. 3 things that are being divided by 6. Let's write them separately. This is a negative 1y, so I'm going to write it as negative 1/6 times y. This is 2/6, so I'm going to put a plus sign and put 2/6 times z. And then this is 4/6, so I'm going to put my plus sign and write 4/6. Now these two fractions can actually reduce, so I would want to do that. Negative 1/6 y cannot reduce, so I'll write it as negative 1/6 y. 2/6 becomes 1/3, so I'm going to write positive 1/3 in front of the z. And then 4/6 becomes 2/3, so there's 2/3. And that's it. I solved for y, and I got this big expression with 3 fractions, and that's all I needed to do. Let's look at one more example, and again, I'd like to make this a try problem. The formula to find the angle measures of an isosceles triangle is shown right here. I would like for you to tell me which of the following equations can be used to find x. Simply solve for x and tell me which one of these answer choices that is. Please pause now and try this problem yourself. Okay, thanks for trying that problem. First, I identified the variable that I'm looking for, this x. I subtracted y from both sides, and I wrote my variable first. And then I divided by 2, and I separated my 2 parts into 2 fractions. And I got this. When I looked at my answer choices, I did not see that answer choice. So sometimes we write them in multiple forms. So I went back to this big fraction that I had originally, and I said, you know what? I think they wanted me to do 180 and take away the y, and then all divided by 2 and leave it like that, because that was answer choice A. So hopefully you were able to identify that, and we'll practice this more in class. Thanks for watching. Bye-bye.